Imagine standing in the Arctic. The wind is cutting through your clothes like a blade. The temperature is far below zero. At -40 degrees, exposed skin can begin freezing in minutes. There are no heated buildings, no electric blankets, no firewood stacked nearby, just endless snow, frozen land, and deadly cold. So what do you do if you want to survive? You build a shelter, but not from wood, not from stone, not from animal hides. You build it out of snow. At first, that sounds completely ridiculous. How could a house made from frozen water possibly protect you from freezing to death? Shouldn't snow make you colder? And yet, for generations, Arctic peoples built igloos that allowed them to survive in one of the harshest environments on Earth. So, what's the secret? How can something so cold become a life-saving shelter? The answer is a brilliant combination of physics, insulation, body heat, and human ingenuity. And once you understand it, the igloo becomes one of the smartest survival designs ever created. Welcome to Everyday Things Explained. Today we're going to explore this topic together.
The first thing we need to clear up is a very common misunderstanding. An igloo is not made of solid ice. And that difference matters a lot because solid ice is actually a poor choice for staying warm. It conducts cold much more easily. If you built a shelter from thick, clear ice alone, it would do a terrible job holding in heat. But an igloo is made from compacted snow, and snow behaves very differently from solid ice. Why? Because snow is filled with tiny pockets of trapped air. In fact, snow can be made up of 90 to 95% air. That means when you look at a block of snow, you are not looking at a dense frozen brick. You're looking at a material packed with microscopic air spaces. And those little air pockets are the real secret, because air, when trapped and unable to move freely, is one of nature's best insulators. That is the same reason a winter jacket keeps you warm, the same reason down feathers work, the same reason foam cups protect your hands from hot coffee. They do not create heat. They simply slow down heat loss. And that is exactly what an igloo does. It does not act like a heater. It acts like a giant thermal barrier, slowing the escape of warmth from inside while blocking the brutal cold and wind outside. So the real genius of the igloo begins with this simple truth. It is not a house made of ice. It is a shelter made from air trapped inside snow. Now, here's the next important idea. Even the best insulation in the world is useless if there is no heat inside to begin with. An empty igloo is still cold. If nobody is inside, it does not magically become warm on its own. So where does the heat come from? From the people inside it. The human body is constantly producing heat. Even when you are sitting still, your body is burning energy and giving off warmth. In a normal outdoor Arctic environment, that heat disappears almost immediately into the freezing air. But inside an igloo, something very different happens. The insulated snow walls slow the movement of heat outward. The wind is blocked. The warm air produced by your body begins to stay inside instead of being instantly stolen by the outside environment. And historically, the Inuit often added another source of warmth. A small stone oil lamp called a kulik, traditionally fueled with seal oil. That tiny flame, combined with the body heat of the people inside, could make a remarkable difference. In some cases, the temperature inside an igloo could rise to around 60 degrees Fahrenheit, or about 15 degrees Celsius, while the world outside remained at -40. Think about that for a second. That is a difference of roughly 100 degrees Fahrenheit between the inside and the outside. Not because the igloo is blasting heat like a furnace, but because it is extremely effective at holding on to the limited heat available. That is the principle that makes the whole structure work. An igloo is not warm because snow is warm. An igloo is warm because snow can prevent warmth from escaping. The material matters, but the shape matters too. A traditional igloo is not just a pile of snow blocks stacked together randomly. It is carefully designed. Its dome shape is part of the reason it works so well. First, the dome is strong. Snow blocks arranged in a curved pattern help distribute weight evenly, making the structure surprisingly stable. That is important in a harsh environment where collapse could be deadly. But the dome also helps with heat. Warm air naturally rises. Inside a rounded dome, that warmer air can collect higher up rather than being lost through flat corners or weak angles. And the smooth curved shape also reduces the interior surface area compared to a box-like structure of similar size. That means there is less area for heat to escape through. But perhaps the smartest architectural feature is something many people never notice: the entrance tunnel. In many traditional igloos, the entrance is built lower than the main floor level. That sounds like a minor detail. It is not. It is brilliant because cold air is denser and heavier than warm air. So cold air sinks downward. That means the coldest air tends to settle in the lower entrance tunnel, while the warmer air remains higher up in the main living space. In other words, the igloo is designed to trap the cold below you. And that leads to another smart feature. The sleeping area is often raised above the lower level. So while the coldest air drops into the entrance zone, people rest in the higher, warmer layer of air above it. This is not accidental. This is a design based on a deep, practical understanding of how air moves. No thermometers, no engineering software, no modern insulation science textbooks, just careful observation passed down through generations. Here's one of the most fascinating parts of the whole story. Once people begin living inside an igloo, the shelter can actually become even more effective. Why? Because the heat inside slightly warms the inner surface of the snow walls. Not enough to melt the whole structure, just enough to soften or melt a very thin inner layer. Then, as that moisture refreezes, it forms a thin crust of ice along the interior. That icy layer helps seal small cracks and gaps between the snow blocks. The result? The igloo becomes more airtight, more windproof, more resistant to drafts. And in the Arctic, wind is often just as dangerous as temperature itself. A strong wind strips heat away from your body much faster. So stopping airflow is absolutely critical for survival. That means the igloo is not just an insulated shelter. It is a shelter that can partially self-seal as it is used. The people inside help improve it simply by producing heat. It is an elegant system. Snow provides insulation, body heat warms the interior, the walls harden and seal, and the shelter becomes even better at keeping warmth in. That is an extraordinary example of survival design working with nature instead of against it. To really appreciate the igloo, you have to understand the environment it was built for. The Arctic is not just cold, it is relentlessly cold. Open ground offers little protection. Fuel sources are limited. Building materials like wood may be scarce or unavailable in many areas. And storms can turn deadly very quickly. So the ideal shelter had to meet several conditions. It had to be made from materials already available. It had to be built relatively quickly. It had to block wind. It had to conserve body heat. And it had to function in an environment where a mistake could cost lives. Snow met all of those requirements. To most outsiders, snow looks like the enemy. But to Arctic builders, snow could become a wall, a shield, a survival tool. That is what makes the igloo such a powerful idea. It takes the very things surrounding you, the frozen landscape itself, and turns it into protection. Instead of fighting the environment with imported materials, the builders used a deep understanding of local conditions. That is not just clever, that is advanced environmental adaptation. And it reminds us that true intelligence is not always about advanced machines or modern technology. Sometimes it is about learning exactly how nature works and using that knowledge with precision. When you step back and look at the igloo as a whole, it is honestly one of the most brilliant survival structures ever created. Think about what it accomplishes. It uses snow, a material most people associate with cold, to create insulation. It uses a dome shape to improve structural strength and help manage warm air. It uses a low entrance tunnel to trap cold air away from the living space. It uses raised sleeping platforms to place people in the warmest part of the shelter. And it even benefits from the body heat of its occupants to seal itself more effectively over time. Every part of it serves a purpose. Nothing is random. Nothing is decorative. Everything is functional. That is why an igloo is far more than a snow hut. It is a carefully refined piece of survival engineering. And maybe the most impressive part is this. It was developed not in laboratories, but through lived experience, through generations of people observing snow, wind, cold, and heat, then turning that knowledge into a shelter capable of preserving life in one of the most unforgiving climates on Earth. That deserves enormous respect. So, how does an igloo keep you warm? Not because snow is hot, not because the shelter somehow creates heat out of nowhere, but because compacted snow is filled with trapped air, which makes it an excellent insulator, because the structure is designed to control airflow, because cold air sinks while warm air rises, because body heat and a small flame can be enough when that heat is preserved, and because every part of the design works together to hold warmth where it matters most. What looks simple from the outside is actually a deeply intelligent response to extreme conditions. The igloo is proof that survival is not always about power. Sometimes survival is about understanding materials, understanding physics, understanding nature. And once you do, even snow can become a shield against the cold. If you enjoyed this story, make sure to subscribe for more everyday mysteries explained through science, history, and human ingenuity. Because sometimes the most ordinary things hide the most extraordinary ideas.
Thank you for joining us on this journey through the everyday things explained. Don't forget to like, subscribe, and stay tuned for more stories.